Hi there, I'm Helper Wesley, and in this video we'll be talking about camera controls. So we have this project file from the Changing Animations video, and you'll notice that the play space is rather small, and it's off-center. So to fix that, we'll be going into the event sheet, and here we have two camera controls. One, to, at the beginning of scene, change the zoom to 5, which is 5 times the default scale of the game. Anything below 1 will zoom out, anything above 1 will zoom in. And then we have an action without a condition that centers the camera on the player object. If I open up the zoom action, you'll see that the zoom is 5, but also that the layer is left alone. Because all of the objects are on the base layer, this doesn't need to be touched. And for the camera number, for everything that we're doing in this video, you don't need to worry about it. And now if we preview the game, you'll see that we've zoomed in, and the camera is centered on the player. And this is fine for most games, but sometimes you would rather the camera follow the player rather than snap to them. So to do that, we'll go to the event sheet and delete the camera action and replace it with camera center X position. Change it to set to, and then for a value type in lerp. Lerp is actually a pretty simple expression where the first number is the value you currently have. The second number is the value you want to be at, and then the last number is the speed to get there. So in this case, it'll be the camera X position, comma, the player X position, comma, and then 0.05 as the speed. And then we just copy and paste that down and change all of the X's for Y's to get the Y axis. And now the camera kind of follows the player instead of snapping to them. Now let's talk about different layers. So if I want to make these two objects be on the UI layer in front and the background layer behind, I need to open the Layers tab and create two different layers, one being a UI layer and one being a background layer, making sure that the background layer is below and the UI layer is above so that the background is behind and the UI stuff is in front. And then I open up the Properties panel and make sure to put those on those layers. And now if I were to preview the game, these two things would be where they were originally within the default window frame, because the camera for those two layers hasn't moved. So the UI is fine, but to center the background layer into the back, we're going to add two actions, both at the beginning of scene. And that's a camera zoom and center the camera on the background. But take note that we've changed this to the background layer instead of just the default layer. So in quotation marks, we need to type in the name of that layer. And there we go. And now we can fix the camera within a certain boundary by adding the action enforce camera boundaries. And for this, we can go to the game scene and zoom in and use the mouse to figure out where the end of the game scene is. Down in the bottom left corner, you'll see the X and Y coordinates of where the mouse is. And so we can go back into the event, and we know that the top part of the screen is 0, 0, and the bottom corner of the screen was 486, 124. And now if we preview the game, the camera will follow the character until it gets to that boundary. And this of course works for the other side as well. And if the player jumps off screen, they'll just fall forever, and the camera will stay there. Another useful camera control action is the angle of a camera on a layer. And for this we'll set it to add to on the base layer when the C key is pressed. And so if I preview the game and press C, the base layer will rotate. This won't affect the game in any way, it'll only affect what you see on screen. So you could use this for if you have a scene where the character is climbing up a mountain, or for camera shake. But there's actually a much easier way to do camera shake. If we go back to the game scene, open up the project manager, go down to functions and behaviors, and you'll see that I already have the extension installed. But if I click search for new extensions and then type in shake, it'll be right there, and I can just click to install it. Now if I go into the collision section of my event sheet, for when the character runs into a spike, I can add an action for camera shake, fill in this information, and that's it. When the player runs into a spike, the camera will shake. Editor's note: for lerp specifically, it's a good idea to times it by time delta. That way, regardless of the frame rate, it'll do the same thing. But this has been a tutorial for camera controls. As always, be sure to comment down below and tell us what kind of tutorial you want to see next. I have been Helper Wesley, and I'm glad I could help. Hey there, my name is Helper Wesley, and in this video, we'll be talking about changing animations. So what I've set up here are a bunch of physics objects, some static and some dynamic, and we'll begin by changing the animation of the ball. So if we open up this sprite object, we'll see that this bouncing ball has two animations. The first animation with a single frame, and the second with two. Because the first animation has a single frame, it's considered finished already, whereas the second animation has two frames, so it needs to finish its first frame, and then it would be considered finished. If we didn't want animations to finish at all, we could click loop here on the end, but for this video, we'll leave this unchecked. We could change animations based on the numbers, but for this object, we're going to be changing them by name. This one will be fine, and this one will be hurt. So now to change animations, we need to go to the event sheet. We'll create a new event with the condition if the bouncing ball has a physics collision with the breaking box object, and then we'll add an action and search for animation. When you do this, you'll find all of the actions related to animations, including changing the animation by number or name, changing the animation speed, the current frame, and pausing and playing the animations. For this object, we're going to be changing the animation by name. We'll select the ball, and then when we click into the text box, we'll be given our options. And here we're going to select hurt. And next we'll create another event and click to add a condition, and we'll search for animation again, and we'll see all of the conditions related to animations, checking to see if the animation is paused or finished, what the animation number or name is, and what the current frame of the animation is. We're going to be checking by name. So we'll select the ball again and select hurt, and then we'll add if the animation is finished. And then we'll paste down the set animation action and change it to fine. So now when the ball hits one of these blocks, its animation will change to hurt. And then if the animation is hurt and the animation has finished playing, then it will change back to fine. So now if we preview the game, we'll see the ball bouncing around, and whenever it hits one of the boxes, it'll change its animation to hurt until it gets stuck. Next, we'll be changing by number. If we open up the breaking box sprite object, we can see how the animations are set up. 0 being fine, 1 being a little damaged, and 2 being very damaged. And so if we go to the event sheet and paste down the condition from the earlier event, add trigger once, create a sub-event, and add an action to change the number of the animation of the breaking block by adding 1. And then we can add another sub-event where if the animation number is equal to 2, then we delete the breaking box. But we need to put that one above the number change event because otherwise it would change the number and then immediately delete it. And now if we preview the game, we can see that when it collides with the box, it changes the animation number down until it breaks. And now to make it a little more impactful, we'll add a particle emitter. We'll create a new event with the condition if the animation is 0, and an action to create the particle object at the x and y coordinates of the center of the box. And then create a repeat x number of times sub-event, in this case once, and move the create object action down into that event. And then we'll copy and paste this event down, changing it to check if the animation is number 1, and then repeating 2 times, and then copy that sub-event down again, this time repeating 3 times, and then moving the delete box action down to a sub-event below that, so it triggers once after spawning in all of the debris. And then we need to add the action, change the Z order to 0, so it puts the debris when it spawns it behind all of the boxes. So now when we preview the game, you'll see that when the bouncing ball collides with a box, and its animation is 0, it'll spawn a little bit of debris, and then when it breaks the box, it'll spawn a lot more. And now to show how to do it for a specific frame. Using this platformer example that we made earlier, I added in an event with the conditions, if the player's current frame is 1, while they're running, create a dust particle at the point I created called dust, and then change the Z order to 0, and do this once. So as the character's running, it will spawn dust particles at their feet. And now we're going to use both the numbers and the names for animations to show you how that would work. So I have an object here I've called object with a bunch of different animations, all with names to match. So I'll put a bunch of these in scene and then go to the event sheet. I'll create an event with the condition any button pressed once, and then change the animation of that object based on a number that's equal to, and then I'll type in the expression random in range, with the range being 0 and 5, because there's 6 animations and 0 counts as a number. And then I'll create a second event where if the animation of the object is spike, it'll delete the player if the player is in collision with the object. And now if I preview the game, I can randomize the objects until I find a spike. And then if I jump into the spike, the player dies. This has been a tutorial on changing animations in GDevelop. As always, be sure to comment down below and tell us what kind of tutorial you want to see next time. Maybe we'll add it to the pile. I have been Helper Wesley, and I'm glad I could help. Hey there, my name is Helper Wesley, and today we'll be talking about touchscreen controls. So what we're going to tweak here to make it compatible with mobile is the little platformer level I made for the in-depth tutorial. Most games for a touchscreen are going to require different kinds of input, specific to the game that you're making. So to begin with, if we're making a mobile compatible game, we need to open the project manager, and in the game settings, open properties. Among the properties, we'll find the option for device orientation. Depending on what kind of game you're going to make, picking one of these is important. Since we're going to make a platformer game with a wider resolution, we're going to pick landscape. Picking a resolution that would make sense for a mobile device is important, but since devices are always changing, it's also important to make sure that your game will expand with the screen itself. And since our game is wider than it is tall, we're going to make it so that the game changes its width to fit the screen that it's in. If we didn't do that, we would get little black bars on the sides of the screen. If we preview the game, we can pick out what kind of controls we're going to need. And since it's just a basic platformer, we only really need left, right, and jump. So if I zoom out, we can see the whole screen, and what this black box is the actual resolution of your game, what will be in screen by default. So like I said, mobile controls will be different for each game, but the concept is pretty simple. All we have to do is create a new layer and call it UI or controls or whatever. And then we're going to add sprite objects that are going to act as the actual controls, where I'm just going to grab arrows from the asset library. And then I'll just put those into the game, line them up so they make sense with the game, and you'll probably decide to move these around a little bit based on the feedback you get from playtesting. And then we put all of those on the UI layer, and this way, no matter what happens with the camera on the base layer, the objects on the UI layer are going to stay put. And now if I preview the game, you'll see that they're there, but they're not doing anything. I still have to use the keyboard controls. So if we go into the event sheet, we can create a new event, and put a comment above it to say that these are the mobile controls, and we add the condition if the cursor, or touch, is on the right arrow, then simulate pressing right for the player. And we can copy that event down and change it so that one is for the left button and then the other is for the jump button. So now, when I put my cursor over the button, the character will start moving. The problem here though is that by default, the touchscreen is just moving the virtual cursor around. And so if you wanted to have it set up so that your right hand is controlling jump while your left hand is controlling the arrow keys, you'd be fighting back and forth over the position of the cursor. So instead, we have to set it up so that we're tracking touches instead of tracking where this virtual cursor is. But to do that, we need to go back to the event sheet. We create a new event with the condition at the beginning of scene, and then we'll click to add an action, and we'll search for touch, and then we'll find this event that toggles whether or not the touchscreen moves the cursor. So if we set this toggle to no, and then move this to the top of the event sheet, we'll have a game that allows us to touch each button individually, rather than trying to fight where the cursor is. So now we can do more than one thing at a time. You might not want to do this for every game, but for games with multiple buttons to press, you'll probably want to do this. And now back to what we said earlier about the game expanding to meet the screen that it's in. Because we chose that it would expand by width, it's going to stay still on the left-hand side, but the right-hand side will expand or shrink to fit the screen. So the buttons on the left are probably fine, but the button here on the right will need to move to stay in screen. And then to do that, we just give it the anchor behavior. And for the left edge anchor, we set it to the window right side, and then leave the rest alone. And make sure that you're anchoring relative to the original screen size, so that it stays where it was. And now, if we preview the game, and make the window bigger and smaller, you can see the button pulling itself back in place, relative to the right-hand side of the screen. And one final thing for mobile touch controls is this condition, to check whether or not you're on a mobile device. You can use this condition at the beginning of scene to delete all of your mobile controls, so your events will stay there in the game, but without your controls there on screen, they don't get in the way of somebody playing on a desktop. As always, be sure to comment down below and tell us what kind of tutorial you would like to see next. Maybe we'll add it to the pile. I have been Helper Wesley, and I'm glad I could help. This video is for anybody who wants to make a mobile game. We'll be talking specifically about game inputs and how they work on mobile devices. Now, we do have a video already on touchscreen controls that go over some things that won't be in this video, so be sure to check that one out after this. But we get a lot of people asking about how to control their game on mobile devices. So I'm going to show you a number of ways to interact with and control your mobile game. To begin with, I have a platformer example because that's a great place to start. We have a little platformer character, and they have the platformer behavior. In the event sheet, they're being controlled with A, D, and space, so I don't have to use the arrow keys. Now, the first thing to talk about is that anything that you can do with the mouse and left click, you can do with a mobile device. So a quick example is, I can add the draggable object behavior and drag this object around. This will work the exact same way on a mobile device, because I'm using the left click and mouse. So when you touch the screen, it counts as pressing down the left button, and then you can drag it around the screen, and when you let go, it counts as releasing the left mouse button. So that's the most basic control. Next, we'll go to the object list, and we'll go down through the list and show you what can work with mobile devices. For inputs, the multi-touch joystick controls work just fine on mobile devices because that's what they're meant for, as well as the panel sprite button, sliders, toggle switches, and the text input object. On a mobile device, if you put the text input object on screen and click into it, you should have a touchscreen keyboard show up on screen that will let you type in things for the text input object. But speaking of buttons, there's also an extension called button state. This extension will give you access to hovered, pressed, clicked, and idle as conditions for each object, as well as allow you to control different effects on the object. So if you install that in the project, you can go to behaviors and add button states to your object. Now, if I go to the event sheet, I can go to my player object, and there are button states right here. And again, these all work with the left mouse button, so I can click on my character to interact with them. So if I go is clicked for the jumping instead of the space key, remove that, preview, I can click on the character to make them jump. Normally you wouldn't do that, you'd have a separate button on screen, so let's do that. If I go to the asset store and look up an arrow button. I've got here my object list. If I scroll out, I can add a layer, call it mobile controls, and add that button to the screen. Make sure to put it into the mobile controls layer, and then give that the button states behavior. And change this to the top arrow button being clicked. And now while I use the A and D key to walk around, I can use the jump button to jump. Now, is clicked is only true when you release the left mouse button. So you might want to use is pressed instead, because then it triggers the moment you interact with it. Like I said, anything that works for the left mouse click and mouse controls works with a mobile device. So if I search for mouse, then I can use left mouse button is released, see if it's pressed or held, and even though you can't use the scroll wheel to zoom the camera in and out like you would in some games, there's an extension called pinch gesture that will allow you to zoom in, zoom out, rotate with pinch gestures like you would on Google Maps. And there's another one for swipe gestures as well. The swipe gestures, if I install in the project, I can see all the new swipe gestures that have come into the project now with that extension. And the quickest way to use this extension is by using these two conditions. You can check to see which direction the swipe is moving in. And same with all 8 directions. Now to use the built-in platformer or top-down behaviors, you can add a bunch of buttons on screen to control the different directions and then put them into your event sheet. But you can also use the multi-touch joystick object. So if I add that to the scene, put it on the mobile control layer, stretch it out, I can go to my platformer character, and in behaviors, look up remap. And there's one for platformer and top down. So if I grab the one for the platformer, I can pick which joystick is being used. If I go to the joystick, I can see here which number it is, so I can make sure that that aligns with the number that I have in the behavior. So I'll disable these and preview the game. Now, the joystick is right here, and when I go over, you can see that the platformer character is being controlled by the joystick, even though I don't have the animation set up with the joystick, because you'll still have to set those up in your event sheet. And you can do that by checking to see which direction is pushed in. So if I type in the identifier for it, which for this joystick is 1, I can check to see if it's going in one of these directions. So I can go to where my character animations are happening and set it up so that if joystick 1 is moving to the right, we'll flip the character. If it's going to the left, we won't flip the character. And there we go. Now the animations are happening along with the character. And you can also easily set this up for a top-down character. So if I remove those, zoom back into the play area, and add this character into the scene, I can give them the top-down behavior. Make sure it doesn't rotate. And then give it the remap behavior for the top-down behavior for the multi-touch joystick. I can pick what kind of controller I want. Make sure the identifier is the same. And press apply. And then when I preview the game, this character now moves with the joystick. Let's talk about structures and arrays, the two kinds of variables that weren't covered in the last variable video. And that's because these two are a little bit different. Let's begin with structures. So if I go to the scene variables and add a variable, I can change it to a structure, and from here I can add a variable to that structure. So structures are kind of like folders for other variables. In the variable list, you can open and close them just like you would a folder. And just like in your computer's folder directory, when you're trying to find a variable, you first use the name of the parent variable and then the child variable to access that variable's information. And you can actually add a structure inside of a structure and make as many of these as you want to inside of each other. These are most useful for organization because you can do things like this, where you can keep your character stats away from the other variables in your game. So as a simple example, let's set up these stats and have them display in the game. I'll use this text object to show the variables in the game. So at the beginning of scene, we'll modify the text to equal, and when I first start typing character, it will show up in the autocomplete. And then when I select that, I'll be shown the options inside of that character variable. So speed, strength, vitality. So we'll start with speed, and we'll do the same thing again for strength and vitality. And then when I preview the game, you can see the variables I put in there earlier. And that's basically it, because structured variables are really easy to use. But now we move on to arrays. Back in the game scene, we'll go to the scene variables, and we'll get rid of these. So we'll turn this variable into an array. And when I add children to this array, instead of being able to write in the name of the variable, it automatically sets it to 0, 1, 2, 3, 4, and so on, because arrays are meant to be used as dynamic lists, which makes them really handy for things like recording the things that are happening in the game, like in this Papa is You example, where it's used to record your steps in the game and go backspaces when you undo a turn. Or, like what we're going to do in this video, you can use it to preload a path for an object to follow, like in the tower defense example game. And of course I'll link to both of those in the description as resources to help you learn how to use arrays. Now in this video, we're going to make this character follow a path down this road using arrays. So we're going to remove the children variables first, and then change this variable to target X, and make another one for target Y. And what we're going to do is record the position of these points for the character to follow. So first we'll set up the points, which is just a sprite object with its origin point changed to the center, and a variable called ID. Now we'll make a couple copies of this, and in that ID variable, we'll set them to 0, 1, 2, and 3. Because when we set up the array, it's going to start at 0, and then go to 1, 2, and 3. So now in the event sheet, we'll start by saving the positions of the variables in the array. So at the beginning of scene, we'll add a repeat event type, and for the number of times we're going to repeat, we're going to use the number of point objects in the game. So count, and we'll get scene instances count, and we'll type in point. So now this event will repeat 4 times. And then for the actions, we'll go to variables, array, and we'll use add variable array value, and we'll select target X. And since we're creating a variable, we need to select what it's going to be. In this case, it's going to be a number, but you could also make it a text or a Boolean variable. And the number that we want to add is the X position of the point object. Then we want to do the same thing again, but this time for the Y position, and we'll save it in the target Y array. And the last thing is the condition. So we want to check the ID variable of the point object, and check to see if it's equal to the variable child count of target X. So the first time this event triggers, it's going to check the first one because the ID is 0, and then the second time it'll check the second one because its ID is 1, and so on, and so on. So now, if we preview the game with the debugger, we can check the game's scene variables and see that we've recorded all 4 different points. For target X, we have 4 different children, and for target Y, we have another 4. But we have the text object here so that I can show you the variables in real time in the game. So to show those variables in this text object, we need to modify the text object. And to do that, we'll need to use a local variable. So we'll add one to this event and call it step. And then we'll add another repeat event type. Now to begin with, we'll modify the text of the array font object to equal blank. And then we'll repeat this time for the variable child count of the array. We could use target X or target Y because they both have 4. Then we'll modify the text by adding step, the variable, plus dash X plus target X. And for arrays, in order to use them in an expression like we are here, you need to use square brackets. So target X is the parent variable of the array, and inside the brackets, you put in the number or index that you want to pick. So 0, 1, 2, 3, 4, and so on. But in this case, we're going to use that step variable we added earlier. And now we'll add the Y position. And there we go. And then once we've modified that text, we want to change the step variable by adding 1 to it. And this is how step will go from 0 to 1 to 2 to 3 to 4 each time that this event repeats. And now before I preview the game, I need to add one more thing to this expression. And now if I preview the game, we can see our array variables right here. So this first variable to this point. And you can see that the other coordinates are for the other points. Now the last thing to do is to get the character moving. We have a button, and so we'll use that as the condition for the event. But also, the character has the tween behavior, so we can use the actions for tweening to move the character. So in the event, we'll check to see if the button is clicked, and if it is, we'll tween the character object's position. We'll set the identifier to move, and then we'll use target X, for which again you need to add your own square brackets, and inside the brackets we'll put 0. So 0 is the top number in the array list, and so we'll be using the first numbers in the list. And we'll do the same thing for the Y position. So now if I preview the game, if I press next, the tween action will move the character from where they were to the point using these coordinates, the X and the Y, because this is 0 in the list. But now to move to the next point, I would either need to change this number or change the array. So once a position is used up, I'm going to remove those positions from the list. So under variables, inside of arrays, we can remove a variable by index. So in the target X array, we'll remove the 0 index. And we'll do the same thing for Y. And so now, we're going to remove the top numbers from the array. So if I press next, the character moves, but also the entire list moves up. And now if I press next again, the character moves down, and we remove the variables, and again, and again. Now in Engine by default, all that you can do is remove a variable by index, or add variables to the end of the array, so the bottom of the list. If you want more options, there's the Array Tools extension. That extension gives you access to a bunch of tools, like this shuffle action that will let you randomly shuffle the children of an array. The extension also lets you sort, splice, reverse, insert, pop, shift, and do a whole bunch of other things with arrays. If you'd like to learn more about arrays, and watch a video about that tower defense game, then just click on this. Hey there, I'm Helper Wesley, and in this video, we'll be using some commonly used expressions. In the intro Expressions Builder tutorial, we showed you how to search for expressions that you might want to use, but without knowing what your options are, you wouldn't know what to search. So I've made this game, and I'm going to go through the event sheet and pick out expressions that you'll find useful. To begin with, in this game, when you start the game, you get to pick from 3 upgrades. And to create those upgrades, we use the create object action, and then use the expression for the X and Y position of the object. In this case being the room floor. So to get the X position of an object, you can click on the expression builder and search for it, or you can just type it in. If you type in a little bit of the name, the autocomplete will show you the options, and then you just click on it. And if we want to get the X position, we just type in X and click on that. And now we have the X and the Y position of the floor. And then to get that position minus a few pixels over, we just type in -64 in the X expression. And if we go to the object, you'll see that I've moved the origin point to the center of the object, so all of the events calling for the X and Y position of this object will pick that point. So when we start the game, we get one in the middle, one to the left, and one to the right. And then to randomize those upgrades, we've selected change the animation for the upgrade object, and then set it to random in range 0 to 4, because there are 5 different possible animations for this object. So if we type in random, we'll see our options. The first option being random number, which will pick an integer between 0 and whatever the number is you put in there. The next being random float, which will do the same thing, but include decimal numbers between 0 and whatever the number is. And then random float in range, which is a number to a number, and then picking anything in between. And then random in range, which is a number to a number, but it will only pick integers. And then finally, random with step, which is your minimum and maximum, and then however big the step is. But in this case, just like randomizing objects in the changing animations video, we can randomize the upgrades whenever the game starts. Another commonly used expression is the distance between 2 positions. If we use the condition compare 2 numbers, and then type in distance between 2 positions, the X position of the camera, the Y position of the camera, and then the X position of the room we're going to, and the Y position of the room we're going to, and set it to check if it's greater than 5, then we can use this condition to make the character move during the transition of the camera between rooms until the camera gets within 5 pixels. Next is how to round numbers. So in this game, every time you go into a room, the danger level goes up by 0.5. But 0.5 is a messy number. So instead, I round that down to get a nicer number to use for other things later in the game. Floor will take whatever's in the brackets and round that down to the nearest integer. Seal will round it up. Rounding works as you would expect it to. So if it's 5 and above, it will round up. If it's below 5, it will round down. Now, the X and Y position of a point. So on the character, there's a point called gun spot. And if we go down to the events, we'll find one for positioning the gun on the character at the gun spot. Now to make this expression, we just type in the object's name, and then type in point, and then put in quotation marks to kick off the autocomplete, and then we can select the point we want to use. And that's it. Next would be the angle towards position. So when you fire the gun in this game, you experience some recoil. And that works by checking the angle towards the position of the mouse compared to the player. So for this one, we would type in the object's name, select angle to position, and then for the number 1 and 2, it's just the mouse X position and the mouse Y position. And I like to put everything in brackets. And then we add 180 so that the angle is reversed. And then during this timer, we apply an instant force to the object using that angle. And then for knockback on the ghost when the ghost object gets hit, we do something similar. We just check the angle of the bullet instead of the angle towards the mouse. And so to do that, we just type in bullet and then angle. And that's it. It's actually really easy to find the thing that you need using this. So I could type in Z and get the Z order, angle and get the angle, center and get the center point of that object, opacity and get the opacity of that object, and so on and so on. But in this case, we're using the angle to apply a force during the knockback timer. Hopefully knowing all these expressions will help you in your future games. As always, comment down below and tell us what kind of tutorial you want to see next. Maybe we'll add it to the pile. I have been Helper Wesley, and I'm glad I could help.
Hi, Max here. In this intermediate video, we'll take a look at external events, external layouts, and global objects, and how they can improve your workflow. So let's say you just finished the first level of your new game and you're ready to make the next one. How do you proceed? Your first inclination might be to copy-paste all of your objects into a new scene and start building out your level, but in fact, there is a much better solution. And that is to use external layouts, external events, and global objects. These tools allow you to detach certain events, objects, and layouts so that you can use them across multiple scenes without having to edit them in two different places. This will save you so much time as a game creator because you'll no longer have to, for example, change the UI layout, change the objects, change the events for every single one of your scenes. You can simply do it once and it'll affect everything, no copy pasting required. Sounds awesome? Well, then let's take a look at how to do this. We'll start with this example from earlier. Once again, we've made one level and we want to make more. However, when we make a new scene, well, none of the objects we've made are available to us. One solution is global objects. We can convert an object to a global one by opening its menu and selecting the Set as a Global Object option. Now, GDevelop will warn us that this action is irreversible, and this is true. So it's a good idea to make a save of your project before making anything into a global object. Once we hit OK, we'll find that our object's text has turned bold and italic to signify that it is now global. Sure enough, when we go to our new scene, we now find our object in our list. We can then repeat this process for every object we want to share between our scenes, and then start building out our level. Playing our game, we'll find that while our level might look nice, nothing actually works. And this is because, well, our event sheet is empty. Once again, we could copy-paste everything from our first level into our second one, but then we'd have the same events in two different places, which we'd like to prevent. So instead, we can use external events. We can find our external events in the Project Manager and under the External Events tab. There we can click to add a new event sheet, and we'll rename it in this case to Level Events. Next, we'll be asked to link our event sheet to a scene, so we'll choose one of our levels. Then we'll simply bring over all the events from our first level into our new external level event sheet. Then we can reference an external event sheet by clicking the plus icon in the top right and selecting Link External Events. This will give us a new item in our list that we can use to refer to our level events sheet. By the way, now that you know how to use external events, it might be very tempting to overuse them. In fact, a lot of the time, especially when you have a smaller amount of events that needs to be used relatively frequently, it might be better to think about using functions or behaviors. Definitely check out our videos on those if you haven't already. At any rate, our game is now functioning. You might notice though that our score and health is missing from the top right. This is because we forgot to include it in our second level. We could copy paste it over from our first level, but, well, maybe you're sensing a pattern here. We can instead use external layouts. External layouts are located right under external events, and we can add a new one much in the same way as with external events. In this case, we'll name this layout UI and attach it to our first level. Then we can bring over our health and score display over to our new UI external layout. And then we'll use the create objects from the external layout action to dynamically load the user interface when the scene starts. Now our UI is loaded and working as intended. And we can now edit it in one place and have it update in both levels. Very nice. Now there's one last use case for external layouts that's kind of important. And this is a different approach to having multiple levels in our game. You see, with our current approach, while we only have to edit our events or objects once, if we wanted to edit, for example, layers or scene properties, well, we'd have to do that still for every single one of our levels. Thus, in some cases, it makes sense to actually build our levels as external layouts and then load them in dynamically later on. Keep in mind that with this approach, you're going to have to manage scene transitions on your own. Generally, this will be done with like a global variable that can be either the number of your level or the name of your next level, such as in this example here. So this has been external layouts, events, and global objects. I hope this video has been of help to you. And as per usual, let us know your feedback in the comments. All right, I'll see you in the next one.
Hey there, I'm Helper Wesley, and in this video, we'll be talking about leaderboards. Leaderboards can be amazing for driving engagement with your game, so it makes me really happy to show you how easy it is to use in GDevelop. After you finish setting up your leaderboard, it's basically just these 3 actions, and then you're done. But first, you need to register your game, and you can do that by going up to File, going to the Game Dashboard, and if your game is already registered, it'll be here on this list, and you can just press Manage Game, but if it's not registered, you need to press this button. If you export your game online, it will automatically register your game as well. But now that we have the leaderboard test project here in front of us, I can press Manage Game. And then if I press Leaderboards, I'll be brought to this screen where I can create a new leaderboard. From here you can pick from a drop-down menu of existing leaderboards in your game, add new leaderboards by clicking here, change your leaderboard's name by clicking here, you can reset the whole leaderboard by pressing here, you can switch between lower or higher is better, and this will determine whether or not it's visible on leluo.io for people to see outside of your game. And from here you can customize your leaderboard. So if I type in gold, you'll see down below it's been added to the end of the number, and the test number is being rounded to the 0 decimal point, so it's only 15. But if I change this to 3, it will round to the 3rd decimal point. And if I put in a -3, it will round in the other direction. But we're just going to leave that at 0. And then finally we can set how the names are displayed on the leaderboard. I usually set it to only the best entries, but you can pick whatever works best for your leaderboard. And now that our leaderboard exists, we can go back to the event sheet, where this first event is sending the score using this action, Save Player Score. And now that we have a leaderboard, we can click here, and now we can pick from a drop-down menu for our existing leaderboards. And then in the next box, you put in whatever kind of variable you want to save as the score, whether that be a time or a point count or whatever. In this case, we have a scene variable called score. And then in the last box, you put the player's name. And for this, we're using the text input object. And in order to tell what's written in the text input object, we can go to the expression builder, type in input, and down here we'll have a selection for the text of a text input object. If we select that, then we can select our text input object, and there's the expression for knowing what's written inside of your text input object. And this next event will display the leaderboard. All we have to do is select the leaderboard that we made. And then finally, when the leaderboard is finished loading, we want to pause this scene that we're on and go to another one. In this case, the scene is called leaderboard. As you can see, it's blank, and the only event has the same condition but inverted, and when that condition is met, it sends us back to the previous scene that we just had paused. So now to see that in action, I can change the score here by pressing up and down, and I can type in a name, and if I press the tick, the score will have been sent. And now if I change the score again, and change this to another name, I can submit the score again, And then if I change the score and name again, and press the tick, it'll submit the score again. And now if I press the home button, it will begin to load the leaderboard, and then once the leaderboard is loaded, it will pause this scene and move to the leaderboard scene so that nothing in your game is being affected while the leaderboard is up. And there we go. We have 7 gold, 5 gold, and 1 gold for the first place, second place, and third place player. And now if I exit this, it will take me back to the original scene that was paused. A big problem with this is that you need to lock off the game so your players can't continually be sending in new scores. So in this example game, for example, when you die, type in your name for the score, and press submit, it goes directly to the leaderboard and doesn't give you the chance to type in a different name. And then when you exit the leaderboard, it takes you back to the beginning of the game again, so you have to get a new score before you're able to submit. And this is what those events look like. If you click into the input object and it is your focus, it will show the submit button. This way you're prepped to type in a name and you don't accidentally submit before typing in a name. And then when you have typed in a name and you press the submit button, it both sends the score and starts displaying the leaderboard. And that's it. It's really as simple as that. If you want to further look into how leaderboards work, I have a link to the wiki and some game examples down below. As always, be sure to comment down below and tell us what kind of tutorial you want to see next. I've been Helper Wesley, and I'm glad I could help.
Hey, Max here. In this video, we'll cover saving and loading. Most games at some point will need some kind of saving and loading. For instance, maybe you want to incorporate a high score, or maybe some kind of checkpoint system, or maybe something even more complex, like multiple save files. In each of these examples, there's something about our game that we want to stay the same between sessions. We can accomplish this in GDevelop through saving and loading, specifically through a mechanism called storage. Let's take a look at some examples. As you can see, we have here a kind of high score system where when we die, we're shown our high score. This high score, though, does not persist between different sessions, as you can see here. So let's fix that. We already have the basic logic for this scaffolded out right here. When the player dies, we check to see if the current score is higher than our scene variable for high score, and if it is, we change the high score to that current score. What we need to do here is save that high score to storage, where it can then be loaded at a later time. For this, GDevelop gives us the write a value action or write a text action for numbers and text respectively. Our score is a number, so we'll choose the write a value action. We'll select the storage, and choose a group of high score. This tells GDevelop exactly where to put our information so that we can retrieve it later on. Finally, we'll write the score itself into storage. Now, in the beginning of our scene, we'll load this high score in from storage. And to do that, we have the read a value and read a text actions. Once again, we'll choose the value option, and we will fill out the same details from earlier. One other thing that's good to be aware of is the existence condition for storage. This allows you to check to make sure that the storage is written before actually reading it. This can be very useful sometimes, so I thought I would at least mention it. Now, our high score is in fact working. By the way, one last thing to mention that I have sort of glossed over is the fact that storage is read into a scene variable. In particular, you're going to have to make sure to initialize your scene variables in the scene variable list before you can read from storage into them. We have a whole video on variables, by the way, so definitely check that out if you're a bit confused by this. Now, for this next example, we'd like to introduce a kind of checkpoint system, where after we traverse between levels and restart our game, we start not from the beginning, but from our last level. The implementation of this is actually quite similar to the high score example. When our level changes, we write into the level group of our storage, and when the scene starts, we're going to read that level into a scene variable. Importantly though, in this case, we're storing our level variable as a global variable. As we mentioned earlier though, information from storage is loaded into a scene variable. Thus, we'll have to use the initial level scene variable as a kind of passing variable to get us from scene to global, which we do in this particular action. Now our game will start from our last level instead of from the very beginning when we open our game. Finally, there are a couple of actions I haven't mentioned that are important. For one, there is the clear a storage action, which will just empty an entire storage, and the delete an element action, which just deletes a single group. Then there's also the load a storage in memory action. This will allow you to save and load much quicker and is useful when you have a lot of stuff you're saving and loading. For example, here we're loading the level, the health, and the score, and as we continue to load more and more stuff, we may find that it will degrade the performance, which is why we've used the load a storage action here. Just make sure to always use the close a storage action after you finish saving and loading. So this has been an attempt at a more basic introduction to the concept of storage. Of course, it goes a lot deeper, so if you're still interested in stuff like multiple save slots or really in-depth save data, then we'll surely be making a video down the road that goes really in-depth on the topic. In the meantime though, the concepts presented in this video should be enough to get you a very long way, so I hope you enjoyed it. I hope it was useful to you, and as per usual, we love to hear your feedback in the comments below. Thanks so much for watching, and I will see you in the next one. Hey, Max here. In this video, we'll go over object picking. So, even if you've never heard the exact phrase object picking before, as long as you've interacted with the event sheet, you're already really familiar with it. Object picking is just a scenario where conditions in the event sheet filter the objects that are then acted on in actions. Our example for this video is going to center around making a simple checkpoint system, like you see here. The checkpoint object itself is just a sprite object with both a checked and unchecked animation. Now, in the most basic case, if we just set the animation of the checkpoint to be checked without any conditions, then, well, it's going to apply to all of the checkpoints. And all of our checkpoints will be activated when the game starts. So we need to incorporate a condition. Really what we want is when the player collides with a checkpoint and the checkpoint is not already activated, then we want to activate it. Notice how the conditions here are acting as a kind of filter, only letting the checkpoints which are colliding with the player and are inactive through. Then when we apply an action on checkpoint, it only applies to the checkpoint that we've filtered, i.e. the checkpoint that we've collided with. Now sure enough, we have activatable checkpoints, and activating one will not activate a later one. However, as we can see here, we have another problem. Checkpoints that we've already activated will remain activated even when we activate the next one. So what should we do if we want only one checkpoint activated at a time? Well, looking at our event sheet, it's not super clear. On one hand, we need to test for collision with the checkpoint, which excludes all of the other checkpoints. But then, on the other hand, we want to deactivate all those other checkpoints, which have already been excluded by our collision. So we're in a bit of a catch-22 here. Fortunately though, GDevelop has exactly the solution. So I'm going to start by removing the logic that checks our checkpoint and adding a new sub-event. And here I'm going to use the condition pick all objects. And when I apply this for the checkpoint object, it'll be as if there were no conditions at all with respect to the picking. So in other words, all of the checkpoints will be back in our picking list. So when we apply an action to the checkpoint, it'll apply to all of the checkpoints. Thus, in this particular case, all of the checkpoints will be deactivated. This includes the one that we collided with, so now we need to make sure to check that one as well. So looking over our event sheet now, we see that first, we uncheck all of the checkpoints, and then we check only the checkpoint that we collided with. And the net result of this is that that checkpoint is the only activated checkpoint. Visually, that looks like this. Next, we'll take a look at how to give this fly enemy here the ability to shoot bullets at the player. We'll start by repeating the timer fly shoot every second, and then for each enemy, we'll create a bullet at its position. Once an object is created, it will actually be immediately picked, which means we can then conduct actions on our new object. In this case, we'll start moving the bullet towards the player. Now sure enough, the bullets will be shot at the player every second. Finally, there are a few extra actions related to picking that are important to bring up. The first is pick a random object, which will just pick a random of the objects selected in the scene. and pick nearest object, which will pick the object nearest to a particular X and Y position. So that's object picking in GDevelop. As per usual, if you have any questions, or if you want to let us know what video you want to see next, definitely leave your feedback in the comments below. Thanks so much for watching, and I will see you in the next one.
Hey there, my name is Helper Wesley, and in this video, we'll be talking about toggling the state of an object with variables. So we'll be using the example I made for the level select video that has a main menu and 3 levels. We'll be starting with a simple mute and unmute toggle. So first we have to create an object and give it 2 animations, one for unmuted and the other one for muted. And then we just put that in scene and go to the event sheet. And the reason this needs to be a tutorial is because you're essentially trying to use one input to get 2 different outcomes based on the state of the object. And I know that when I started out, this was a problem for me. So to begin with, we'll be using a Boolean variable. So we go to the object, add a variable, and we're going to call it mute toggle, and then we'll change the variable type to a Boolean. Going back to the event sheet, we'll add 2 sub-events to this main event, and then move our animation changes down to those sub-events, giving them the conditions: if this Boolean variable is false, the animation will be unmuted, and if it's true, the animation will be muted. And then to make this work, when you release the mouse button, we need to add an action that will change the variable. So we click to add an action, search for toggle, and we'll find toggle the Boolean value of an object variable. And then we just select the mute object, and then type in mute toggle, because that's our variable name. And now, when we release the mouse button, while hovered over the mute sprite object, it will toggle the Boolean value from true to false or false to true based on whichever one it is at the time. And then, after that toggle is completed, it will go down to the sub-events and change the animation based on whichever condition is true. So if we preview this, you can see me clicking on it and the animation's changing. And then to make this actually work as a mute, we can add the actions change global sound level to both events, and making the unmuted 100, while making the muted state 0. This, though, is just the first way that you can do this. And because it's based on a toggle, it can only support 2 different states. If you want something with more states, you can use this second way, which uses a number variable to keep track of which state you're in. So we need to go to the object and change it from a Boolean to a number variable, and then add a 3rd animation that we're going to call half muted. So we'll disable this original event for now, and with some editing magic, we have the sub-events for 100%, 50%, and 0 sound levels. So to begin with, we need to add an action like before to actually change the state, and in this case we'll change the variable mute toggle by adding 1 to it, and then set the conditions to be when the mute toggle is 0, 1, or 2. So now when you click on the button, it will add 1 to it, which will move it down the list and change the volume. But if you left it this way, it would go on past 2 and go to 3, and then never work again. So we need to add another event with the condition greater than or equal to 3. So when this variable gets clicked on a 3rd time and reaches 3, we give it the action to change the variable back to 0. So it cycles back to 0 instead of breaking. And now if we preview the game, we can see this in action. You can see it going from full volume to half volume to muted. And then when it goes past muted, it goes back to full again. These can be pretty useful for menus and user interfaces, but it can also be useful for the game itself. If I open up level 1 and create a sprite object and give it 2 animations, one for being fine and then one for breaking, and then I give the player and this block the platformer and platform behaviors, I can then put those in scene and they would act like those things. But then I'll give the block a variable and call it breaking, and I'll copy that event from earlier and paste it into this level, and then I can modify that so the first time it triggers, it will change it to a breaking state, and the second time it triggers, it will delete. So if I preview the game, you'll see this happening. One last example for cycling. If I go to level 2 and add an object with a bunch of different rune animations, and give it a variable that I'm calling swap, and put a bunch of them in scene, then copy that cycling event over again, and modify it to make sense with this time cycling when it hits 6, because there are 6 different animations. I can create a game mechanic where you're cycling through images to create a combination to get through a puzzle in a game. But this has been a video on toggling the state of an object with a variable. As always, be sure to comment down below and tell us what kind of tutorial you want to see next time. Maybe we'll add it to the pile. I have been Helper Wesley, and I'm glad I could help.